management and including the go-to-market strategy. So I don't know how much background you have about 3D printing. How you've heard, we announced the technology a couple of years ago. We've shipped the first product. We announced the first product last year in Rapid in Orlando last year in May, and we've started to ship this year the first products. Okay, so pretty successful launch, I would say. We're pretty happy with the results and the intent we're doing in the market. As you know, this is not a consumer product. It's a commercial product. Our strategy is really to drive the next industrial revolution and drive really transform manufacturing from an analog market into a digital market. We forecast that we've estimated with analysts that it's about a $12 trillion market, the manufacturing market. So it's a huge potential to tap into. Today, the 3D printing market is tiny, and really our aim is not to only play in a tiny market, but really to contribute amongst other players in the industry to grow the market significantly, to really be a very relevant manufacturing technology in the future. So we've introduced the first products, 4200, 3200, the fused nylon plastic, okay, today thermoplastics. These are some examples, I can pass them around on plastics. We are focused on really driving the next industrial revolution and doing final parts. This is a part of our products. So 50% of the custom plastic parts, meaning non-catalog plastic parts of the 3D printers, are printed by the printer itself. Okay, not because we can do it and make sense. It's because our manufacturing department has told us that this is the most economical and effective technology in order to do it. So we stopped other technologies, and this we produce our own parts. This is a part of the printer. I'll pass it around so you can see it. So we're really working with customers to determine how can we help them produce final parts. You can produce final parts basically because we have the right technology with the right mechanical properties, the right finishing, the right accuracy. We can do the right materials, okay? And then you have the right cost and the right economics. And this is really the right cost and right economics is going to be a key catalyst, one of the friction points today in order to drive changes from analog to digital. You will see this is, we're targeting, 4 or 5 segments. One is healthcare. This is an example. This is an insole. And obviously, everything that's healthcare, each of our bodies are totally unique and personalized. So 3D printing makes a lot of sense because every part is unique. Okay, so I'll pass that around. So this is an insole that you would sculpt your feet. The other segments are aerospace. You can produce very fine structures. Look at this structure. I'll pass it around now. With very low weight, but still very stiff. With the mechanical properties you need. This is something you can only do in 3D printing. Okay, I'll pass that around. We're also going to automotive. Sorry, I didn't bring any parts for automotive, but for very short runs, you can think very luxury vehicles, performance vehicles, Formula One, etc. We're able to basically print parts for very economically for those short runs, and then general consumer goods, which is a bunch of applications that our customers are teaching us. So really, our aim is to do that. In order to do it, I've talked about cost. The other thing that's very important is having the material. If we really want to make an indent on the manufacturing industry, it's about tens, hundreds, thousands of materials. Think of what you have, in front of you, your chair, your suitcase, the cover pieces. Every plastic is different, right? And it's for a reason because it has different mechanical properties. It has different purposes. So if we really want to be serious, we really need to have not only one material, but really hundreds and thousands of materials. So for that, there is no way HP can scale that ourselves. So we've developed an open platform, okay, which we partner with the biggest material companies in the world. We have a funnel. We've partnered with 5 today, but we have a funnel of other 50 material companies that want to work with us. Biggest material companies in the world like BASF, Arkema, or Evonik, that produce many of the plastics that you sit on your chairs, on your cars, etc. They are $20+ billion companies each. And they're developing materials on the Google platform. So in the very near future, we can not only produce polyamide 12, like the parts that I'm showing right now, but we can produce really any part, okay, with many other materials, meaning flexible materials, etc. If you sat on the session with Shane this morning, he talked about, being able to print circuits, etc. We're able to do it because we leverage the inkjet technology. And today, the process, how we fuse the plastic, is we fuse a very fine powder of plastic powder, and we fuse it. We jet a set of agents that then absorb the heat and then fuse. We leverage the inkjet technology, the same inkjet technology that we have in the rest of the portfolio. And therefore, today we're using 2 agents, but if you think about our inkjet technology, you can have multicolor, right? So eventually, I didn't bring any color parts, but we'll have, multicolor parts. In the future, you can also put other type of chemistry. For instance, you can put chemistry that is not color, but that conducts conductivity. So that means that you can, paint or produce traces of the parts that will have conduct the electricity. That means that you can design integrated circuits within the part. That means that, in the future we have the potential that not only every product is connected, but every part within the product can potentially be connected. Okay, so we're very excited about the technology, the possibilities that it brings. The reception in the market has been very, very good so far. So, and with this, I talked a lot. Sorry about that. I'm going to open for questions. Yes, any questions? Please.
Have you seen any of the existing printing partners show any indication of 3D savvy, or
there's been some companies that have done some partnerships. There is 2 bigger established. I mean, it's a very fragmented industry, rather a very small industry. And to be honest, we're not very focused on the current. Obviously, we are, but we're not. I mean, if you look at longer term, we're not very focused on the current players in the industry. Really, our aim and what we consider competition is the analog technologies that today do the 99.9% of the $12 trillion manufacturing. That's what we're after. And that's where, we want to compete against and really have, the right mechanical properties, the right materials, the right economics to be able to compete against those. We haven't seen any relevant moves from any other printing competitors in 3D that I would call out relevant. But that's really your competition. If you ask me who your competition is and who I'm designing the products and the strategies for, the strategy for is really to compete effectively against injection molding and milling.
Along those lines, I mean, like you said, it's a $12 billion or $12 trillion industry. So have you received any blowback from the manufacturing industry?
No, a blowback in terms of
or criticisms or wanting you to switch course, pressure?
No, not at all. I mean, I think people is very excited. We have customers that are manufacturers. They're very excited about the possibilities. Obviously, we will not eat the $12 trillion market in, it will take decades, okay? So, but it means it's a huge market for us to tap into. And really, we believe it's complementary. If you print, I don't know, if you do cup bottles for water, it will continue, and you print millions of it. It will continue to make sense for you to manufacture, right? But if you want to enable a short marketing series of that, or you want to enable a customized part, or you want to enable, short runs for whatever reason, then it makes a total sense. Our technology will enable you to do that economically and faster than a traditional technology. So I think they'll complement, and we'll see many of our customers continue using both analog and digital technologies.
What kind of machines do you have? Because we have today the small machines that I can buy and use in my house.
No, thank you for the question. Today your machines, I didn't bring one with me because I couldn't. They're big machines, okay? They're industrial. They are big industrial machines, so they would be size of those 2 tables. We have a printer and a post-processing station, so they're not for an office environment, okay? And they don't need a complicated setup, but it's an industrial, it's a professional type of equipment. Okay, we're really focused on. We believe that the opportunity is more on going after final part, both prototyping and manufacturing of final part, and not really on consumer as of yet.
And about the cost?
The cost of the products? The cost of the products is around, our solutions start at around $160,000. So it's a professional products, and then we have a lineup from there that goes up. But then they deliver very competitive running cost. So you can get parts that are, very economical, very economical.
when will you be printing with other materials?
So today we are, the process that we've announced, it's for thermoplastics. So it's a number of plastics. Today the parts that I've handed around, they're polyamide 12 parts. Okay, means that this is polyamide 12. It's very convenient, but it's a rigid plastic. We are, thanks to our open platform, we're going to be releasing a number of other plastics that our customers can print with the products that they've bought. Plastics like TPA or TPU, that is a more flexible plastic, similar to we could do things like my wristwatch. Glass beads, fire retardants. I mean, we're working on a roadmap of plastics. But right now, what we have announced, it's only plastics.
Do you have an idea of when you metal or?
Right now, it's with Chain. It's on the HP Labs. Okay, where it's with our research team. Okay, so I don't have a date for that. But we're researching, possibilities with many other materials.
And you provide these plastics, or there are third party that you can buy it?
Both. So that thanks to our open platform, we have a HP branded materials that we will sell. But then we work with many of these other companies, call it BASF, Avonic, or Kima, that they will sell plastics for our products. Okay, and they will sell it also through our go-to-market. So basically, our customers can buy easily both HP branded materials and third-party materials that have been certified for our products.
Imagine you print 3D printer, put some parts within the printer were 3D printed.
Yes.
Does that mean you can actually print a replacement part, a tech can come out, anticipate a failed part, print a replacement part in the printer?
Eventually, yes. And some of our customers are looking into that. Spare parts are one of the more painful businesses, because when you introduce a product, you have to produce spare parts, so you can anticipate if, like HP, we sell on a global basis, that if I have a product in South Africa, in Minnesota, Illinois, New York, or somewhere else in the world, I have a spare part there, right? So the inventories of spare parts are huge. There is many of our customers have the vision that they can actually, and it's our vision as well, that rather than distribute spare parts in the world, you can distribute the digital model in the world, and then be able to fulfill that model, to put that model from digital to physical, where the demand is, right? So we're working with our spare parts team as well right now to do it. This will be one of the trends. One of the challenges is that many of the parts have not been designed for additive, and this is the other trend: is as these manufacturing technologies, 3D printing and HP 3D printing and others, become mainstream for manufacturing, it will make much more sense to really design for additive, right? And as we see those designs, it's the whole process and logistics and supply chain will become much more efficient.
About 5 minutes left.
Okay.
That's good. Also going to sound very untechnical and dumb, but the output that the printer captures and then prints, I'm assuming is highly dependent on the nature of the application that's generating it. Yes or no?
Absolutely.
Okay.
Yeah. You mean the digital model or the? Yeah.
So how much work needs to be done to make this more predominant with the CAD and the design and all this?
That's a great question.
software?
So one of the things that the standards of 3D printing in the industry of language, let's say the PDF, it was called STL, and it was a very archaic language. So the first thing that we did a couple of years ago is we created a consortium with industry players, including all of our competitors, saying, look, if we want to advance in this industry, we really need to advance the language, right? And we call it 3MF, which is, and it's a consortium that is, Siemens, ourselves, Stratasys, SolidWorks. I mean, we got, the key players, software players, also hardware, to really, let's agree on the standard, how we create the standard. And today, for instance, with the current STL standard, you could not bring color. So when you have printers that eventually bring color capabilities, you need to have a software that is able to design that, right? So that's how we, addressed it, by basically being founding members of that consortium. But that's key. The whole industry needs to go together, right? Including the software and CAD applications, to really take advantage of all these
Well,
possibilities.
particularly if you can manufactured with other materials, right?
Yes, exactly, yeah.
And that's just, how long has the consortium been in place?
2 years. So the format is existing and the language is existing. It's called 3MF. So it's just a standard, like, how we call it, like the PDF for today.
Right. Thank you.
All right.
So the
More
next,
questions?
the
All right.
next round is your analyst. You're gonna go to room 6, which is at the end of this hallway on the last door on the right. And if you're a reporter, you can go just to have the break room for 30 minutes, and then we'll swap at 3:30.
Thanks for your questions.
Thank you very much, that was really interesting.
I'm gonna grab the parts.
Please do.